If you've ever used a computer, you know what one of these is. This is a keyboard. You push a button, and it puts that character of the button on the screen of your device. It's one of the main peripheral systems you use to work with digitally. And this is a typewriter, an ancient ancestor to your keyboard. You push a button, and it puts that character on a sheet of paper. But there's a missing link between these two. The electric typewriter. All the functionality of the typewriter, twice as heavy and needing an outlet to work. I picked this one up about 5 years back for the novelty, but it's been sitting around ever since. If only there was a way for me to be able to use this daily, in such a way that I could connect between modern working needs of a keyboard and my desire to click-clack away on a typewriter. The idea is simple. Find a way to hijack whatever system is in place that determines when a key is pressed, send it to an Arduino, and make that Arduino send the same character to my computer. But first, how does a keyboard work? A keyboard works through the use of a matrix, having both rows and columns. Each key sits at the intersection of one row and one column. A keyboard controller constantly scans the rows by sending out a set voltage, one row at a time. If no keys on that row are being pressed, nothing happens, and the controller goes on to the next row to continue. But if a key is pressed, it completes a circuit between that row and column, allowing the voltage to pass through to that column. When that happens, the controller sees both the row and column as being powered, and knows to send the scan code for that character to your computer, where your computer decides how to interpret it. We can confirm this relates to our typewriter by using a multimeter. Hey, Fushimi here, sorry, forgot to mention, the keyboard is made of two boards, basically. One is the flexible overhead board that actually connects to when the key is pressing down, and that's where the connections between the rows and the columns are made, and the lower board that actually does all the logic. We can see multiple solder connections, which seemingly relate to each of these paths on our flexible board. If we send voltage through any two solder joints, we should be able to print out a character. And we do, occasionally. For now, let's say that any two connections that don't print a character are likely to be connecting either two rows, two columns, or just not mapped to any character. Thus, if you wanted to somehow do something on a key press, you'd attach wires here and connect them elsewhere to do with as you please. With that, all that's left is to determine which path combinations make what characters, and to do that, we're going to need to make a map. Let's do that now. I'll import my image of the flexible board into Inkscape, and trace out each path in a different color. It's now a bit easier to make out different paths, but it's not easy to read just from a glance. For that, let's number each path 1 through 16 and type out a 2D array. Rows will be the bottom 8 paths, and columns the top 8, with each element of our array being the character at that row column position. This is much easier to read, and will be quicker to reference if we want to know what character is at lines 9 and 14, or what row column position make J. Side note, you may assume that since it's just rows and columns, you could potentially wing writing out this array. After all, a typical keyboard has 6 rows maximum, and the columns would be a game of guessing correct. But let's make a quick keyboard chart. I've made the background of each key its row color and added a symbol in the column color to show you where everything is in relation to their positions. You can immediately tell there would not be any guessing on which lines would make what characters without mapping this out as we did. Now that we have a digital map, let's go on to the physical bits. Soldering. Soldering is quick and simple. First, strip the ends off the mold wires and tin them. Once everything is ready, solder them directly onto the very same solder connections we mentioned earlier. Then, we just plug each of our newly attached wires into our oh-so-very convenient Arduino Uno, making note which wire is connected to each connection point. Since we already made our map, we can easily see which Arduino pin is connected to what row or column. Then it's onto the coding. The first draft of code is pretty simple. We start off just by printing each character to the terminal. Just in case something goes catastrophically wrong, we can just end the IDE rather than the entire computer. We basically run a loop to read the rows, in which each has its own loop to read all the columns. If we see both our row and columns on, we print that character. I also set up a 2D array based on the map we wrote earlier, so we just need to reference that to determine which character to print. We'll also throw in some debounce checks and when the last time we printed that character. A debounce check is necessary to make sure there's no potentially bouncing of the keys that causes the character to be printed more than required. Same thing with the last time printed, but on a more human scale. Technically, these could be the same check, but I'm lazy and don't want to go back and test this all over again. So 2 separate checks they shall remain. After a quick test, everything seems to be in order. Now all that's left is to switch from print command to the keyboard library, and this should be nearly done. I just have to import it and switch the print command to the keyboard send command and... Wait, why isn't this working anymore? Okay, so fun fact, the Arduino keyboard library is not compatible with the Arduino Uno. Who knew? If I want to use the library, which I very much do, I need to have a board with the right architecture. Luckily, Arduino documentation is always handy and has a list of such of these boards. After a quick perusal, I'm deciding that I wanted the smallest possible board so I could hopefully jam it into the casing later. I went with the micro. A week later and I'm back on track. I moved the wires over from my Uno to my new micro, again making sure I keep track of which wires go to what pins. And by that I mean, during testing, I forgot to change the input variables in the code and spent nearly an hour cursing myself as everything seemingly fell apart. But once that was sorted, everything worked exactly like it did last time. We're back in business. Before we do some final touches on the code, let's sort out this whole wire situation. As much as I like the homemade bomb aesthetic, it would be better overall if we could have everything in one neat package, which means moving the Arduino into the typewriter. Looking at an overhead, it seems like there's plenty of space, but a majority of that is being used by the typewriter head and wouldn't be usable once it gets moving. So instead, we're left with only this small strip of real estate to choose from. I decided to park my Arduino here, since A, it fits quite nicely, and B, it uses the least amount of wire. However, it still needs more wires than I currently have attached, so I quickly desolder my previous wires and resolder some longer ones. Once that's done, the Arduino can comfortably stretch to its new home while still being attached. And since we're on the topic of looks, let's give our Arduino cable its own mini hole. There isn't any space beside the power cable once the case is on, so making our own is pretty much the only option. I use a rotary tool with the smallest bit I have to carve out a hole just large enough for the cable to fit, then sand the edges slightly. It looks a bit rough, but it works for now. Let's get back to coding. Now, originally, the plan was to code for the caps lock and shift keys within the code, something along the lines of setting a variable that only came undone once caps or shift was released. But for some reason, I just could not get this to work. You might be saying, but that LED there says shift is being held. Couldn't you just use that? And the answer is yes. Don't interrupt me. Once I acknowledged that I have to use the LED, I implemented a voltage divider to connect between the light and the Arduino to determine if the LED is on or not. Code changes are simple. Add a declaration for the voltage pin and a variable to hold the light status in the loops. Last change is to update our character printout by adding an if-else to decide which of two arrays to use when printing a character. This second array holds all the uppercase and special characters that you would typically see when using space or caps lock. And we're done. Let's see the keyboard in action. Things that change if I ever return to working on the keyboard. 1. Make the left shift key work. It didn't work when I bought it, it doesn't work now. Would be extremely helpful to have, very self-explanatory. 2. Auto enter when it reaches the end of the paper. I did attempt to send a signal to the enter button to be pressed after a certain amount of keys, so you'd never actually go off the end of the paper, but never got the timing right. It always sent a bit of junk and occasionally an enter key. As it stands, if you go too long without typing a new line with enter, it'll start screaming at you and no longer type. It would be nice to have it auto-enter, maybe with a special character or some ellipses to show you haven't manually typed a new line. 3. Better wire management. This looks like hell, and I do not envy potential future me's need to re-understand all these wires and pull them out individually. Either smaller, making them a ribbon, or some other alternative to make the insides look pretty. Some future ideas? 1. LED keys. It'd be extremely cool to have this thing light up. A true sensory experience. 2. Cool casing. I want fun colors, or a nice modern black, or something see-through and transparent like all the cool technology used to be. Anything besides crusty aged plastic. It'd be a hassle to model initially, but after that you could go basically wild with your imagination on how it looks. 3. 2 giant paper wheels on the back. One dispensing paper yet to be written on, and the other one containing all your ravings. No need to constantly switch out paper, it's its own self-feeding machine.